So today I'm going over finding areas of polygons. You can find the areas of polygons by breaking the polygons into smaller shapes. Then you can apply area formulas that you already know. And this is for triangles, trapezoids, rectangles, parallelograms, rhombuses. Any one of those will help you to find the entire polygon's area. So we got a couple pre-solved examples I'm going to go over first. First one says find the area of each of these polygons, and I'm going to do A first here. And so we see that we have a rectangle and we have a triangle. And it's going to just walk us step by step how to do that. Okay, so the first step says draw a horizontal line segment on the diagram that divides the polygon into a rectangle and a triangle. Okay, so that's what it's telling you to do where you see this dotted line. It says separate it out into shapes that you can find. So we see a rectangle and we see a triangle. Okay, so we did that. Alright, next, find the area of the rectangle. Area of a rectangle is base times height, or sometimes you'll see length times width, but your length would be your base. So this is either your length or your base of 16 centimeters. And then your height is going to be 7 centimeters here. So that's for your rectangle. So we want to find that area. Base times height, 16 times 7. So we notice that we have 112 square centimeters. So remember, it's square centimeters because you're multiplying centimeter times centimeter. That gives you squared centimeters. So you're at 112 centimeters, or square centimeters, just for the area of this rectangle. What about the triangle? How do we figure out what the dimensions of the triangle are? Well, we have to look at the rest of the numbers that are given for us. So we see that our height on this left side of the polygon is 13 centimeters. Well, we don't need 13, but we do need to know that the height of this rectangle underneath is 7, and we have just a little bit more added on because of the triangle. So 13 minus that 7 is going to give us that little bit more. So we're going to realize that 13 minus 7 is going to give us a height of 6. Okay, so that's where we're going to find that this is 6 centimeters. Okay, so next we need to find the base. Okay, well, we have a total base of 16 for the rectangle, but we see that this half right here, or this part right here that goes to here, is 8 centimeters. So 16 minus 8 is going to give us the rest of this, which is going to be 8 centimeters. And we see how we did that right here, just subtracting the largest number from the smallest there, and we found what our other dimension was. So now we need to know area of a triangle is 1/2 the base times its height. So we got 1/2 of 8 centimeters times 6 centimeters, and we see that right here. So 1/2 times 8 is 4, 4 times 6 is 24, 24 square centimeters. Alright, so then it says add the areas from step 2 and 3 to find the total area. So I found that the rectangle was 112, my triangle was 24, so those together is going to give me my total polygon with 136 square centimeters. So that's how you find it with a rectangle and a triangle. Okay, so our next example. Our next example here, example B, we see that we have kind of this L shape over here where the piece missing, but it's got some dots drawn out like it's telling us to try a different way. So let's see what it's telling us to do. It says extend the top edge and the right edge of the polygon to form a square with side lengths of 60 feet. Find the area of the square. Okay, so why does it tell us that? Because we see that this side's 60 feet and this side's 60 feet. So we can complete a square by doing this, extending out to the right and down. So with that, we can find our total area of a square, which is the side times the side, or 60 times 60. And we see that that gives us 3,600 feet, or square feet, for the area of the square. Alright, so now that we have that area of the square, it says notice that you drew a rectangular piece that's missing. We want to find the area of that. So how do we figure that out? Well, we need to figure out its base. So it says, alright, well the base total is 60, but we have 20 that's already showing. So we need to know that missing other part is 60 minus 20 is going to give us 40. So our base for this missing piece is 40 feet. Okay, well how about the height for that missing piece? Well, right now we have a height of 60 total, but we see over here that we have 30 feet that's already given to us in the solid piece. So 60 minus 30, this other piece is also 30 feet. Okay, so we are solving for that final missing section that's going to be a 40 by 30 rectangle. Alright, and when we do that, our area of a rectangle is base times height, so 40 times 30 is 1,200 square feet. Alright, so we have, if this was a complete square, it'd be 3,600 square feet, but we're missing 1,200 square feet of that, so we need to subtract it out. And then we find that our total area of that shaded part right here is 2,400 square feet. So that's how we would work on that. It says, describe another way. If we look and reflect on this, is there another way to find the area of this polygon? So if you were looking at this polygon and you didn't want to complete and make a square, you could also look at just how we did it before, where we drew a line that kind of separated out two different rectangles. So you could also do two areas of rectangles and do a 20 by 60 and a 60 by 30. Or, not a 60 by 30, a 40 by 30. So we would have to remember that we're subtracting 20 from that 60. So it would be 40 by 30 here, and we have 20 by 60 here. We could do it that way, or we could just cut it off here, and we could have 30 by 60, and we could have 20 by 30. So depending on which way you look at it, how you see to solve it first, there's multiple ways that you could go and try to solve it, and all of them will give you the same answer of 2,400 square feet if you do it right with the areas. Okay, so that gives us two solved out examples for us. Let's work on one that's not solved out. Okay, so we're seeing number 3 here. Number 3 gives us a couple different views, but it looks like we can do something similar to the last thing I was talking about, where we can split it into two rectangles. So I myself would automatically just draw a dotted line right down there, so that I would make a 4 by 8 rectangle on the left, and let's see what this would be. We have, looks like it's 6, and this total length is 8, but it looks like the sides that haven't extended out are 3 each. So I've got 6 that aren't being used for this, so it looks like this part right here is going to be 2 meters. Okay? So when we're looking at that, now I want to do area of, let's say, I want to call this rectangle 1. It's good to label what you're working on so that if you are showing work, we can find an error easier. So this is rectangle 1, and I'm going to call this rectangle 2. Just like that, R1, R2. So now I want to find area of R1. And we know that it's base times height still. My base for that rectangle is going to be 4 meters. My height for that rectangle is 8 meters. So 8 times 4 is what we're looking for that area of rectangle 1. 8, 16, looks like it's going to be 32 meters squared. And that looks like that. How about area of rectangle 2? Still base times height, nothing changing there. But now we have a base of 6 meters, we see right here. And we have a height of 2 meters, this part right here. So 6 times 2, we have 12 square meters. Now I want to find my total area, a total, T-O-T. Okay, with that one, that is AR1 plus AR2, which is 32 meters squared plus 12 meters squared, or 44 square meters. Alright, so that's how we would solve number 3. Okay, well, how about number 4? Well, when we look at number 4 here, there's a couple different options you can do. There's one thing that comes into play is, do you remember the area of a trapezoid? That's the hardest thing, because if you know the area of a trapezoid, you can do 2 steps on this equation. If you don't, you have to break it into 3 different things. If you do know the area of a trapezoid, you can just separate it right here, and you have your first base and your second base of the trapezoid, and we can figure out our height right here. With 36 minus 18 will give us our height of that trapezoid. But if you don't know area of a trapezoid, you would then have to do 3 steps where you have a rectangle, a square, and a triangle. So depending on what you want to do, you can solve it in 2 different ways at least. I will show, let's try, I'm going to use the trapezoid one first, just because I want to refresh how to do trapezoid area. So let's go with that. I'm going to first draw a little dotted line here. And now I have, for my 2 different ones, I want to solve area of a square. So I'm going to do AS and ATR for trapezoid. Okay. So with that, AS for my square is going to be side squared, okay, or 18 squared. 18 squared. It's the same as 18 times 18. And seeing that I don't feel like doing that in my head, let's see if I got the calculator quick. There it is. Just because I want to save time, 18 times 18 gives us 324. So this is 324. And I didn't put my measurement, my unit of measurement, but you should always go along with your unit of measurement and make sure that you're writing that as you're writing out your equation, like I did in my first example. This is going to help you to not forget to put that, because as you get further on in school, it's very important to know what your unit of measurement is, and if you don't have it, you're wrong, no matter what. So you need to make sure that you don't forget your units of measurement. So I would squeak in that you're using inches on all of these, like that, just so we don't forget that we're working with inches on this. Alright, so here comes the big one, area of a trapezoid, so ATR. So my area of a trapezoid is 1/2 of its height times its first base plus its second base. Okay, so 1/2 B1 plus H plus, or 1/2 H plus B1, or times B1 plus B2. So with that, what is, we got 1/2, what's my height? So it looks like this whole thing is 36 inches. And we have 18 for this square. So 18 and 18 is 36. So it looks like this part right here is going to be 18 inches from where we start our top of our trapezoid to our bottom. So 18 inches for our height. And now we have 2 different bases that we're looking for. Okay, so it looks like it's telling us that this right here is 9 inches. So if this is 9 inches from here to here, and the total length is 18, or the total height here is 18 inches, then this here is 9 inches as well, from this point to the bottom. So we see that one base is 9 inches and the other base is 18. So we're going to have 1/2, 18 inches, times 9 inches plus 18 inches. Okay? And we can rewrite that as 1/2 times 18 is going to give me 9 inches. Well, what's inside here? 9 plus 18 is going to give me 27 inches. Alright, so I haven't squared anything yet because I haven't multiplied it inches to inches at all. I've just done some addition and done some multiplication outside here without units. So now I have 9 times 27 is going to give us our final area of that trapezoid. So we have 9 times 27 gives us 243 inches squared. Now, since it's inches times inches, we're going to be squaring that. So we haven't found our final area yet, but we found the area of our square was 324 square inches, and our area of our trapezoid was 243. So area total is going to equal AS plus ATR, or 324 inches squared plus 243 inches squared. And let's see, I don't want to have errors while I'm talking, so I'm making sure that I'm doing it on a calculator. Recently I tried doing a lot without and made lots of errors. So 567 inches squared is going to be our total area for number 4 here. It's 567 inches squared. Okay? Alright. So now we have some real world problems. This one's another example. Okay? And it says, let's see. The diagram shows the shape and dimensions of Teresa's rose garden. Find the area of the garden. Okay, so we look at this, and this is a simple one still, but it's just we're looking at rose gardens instead of just a parallelogram or a polygon. Sorry. So with that, we still find that we can break it into 2 different segments of rectangles. And with this one, we aren't doing the complete the square because it's not a complete square out here. We could still do that kind of thing where we could extend this out and make a rectangle from it and find a missing piece. But we can also just solve 2 different rectangle equations and be done. So that's what we'll do. So for this, it tells you to draw a horizontal line. So this dotted white line, this is our first step. We want to separate it out into what we're going to be finding areas for. So we have a top rectangle and a bottom rectangle. So first we're working on the top rectangle. Area of a rectangle, base times height. So we see that our base is 15 and our height is 9. So 15 times 9 gives us 135 square feet. Then it says find the area of the larger rectangle on the bottom. So we don't have all of the values yet, but the one that we're missing is the height. And we notice that the total height of this rose garden is 18 feet, and 9 feet of it is for the top part. 18 minus 9, we find that this is 9 feet as well for a height. So we're just finding the area of the rectangle on the bottom by a base of 24 and a height of 9. So we're going to multiply 24 times 9 and get 216 square feet. Once we've got the areas of the top and bottom rectangles, all we do to find the total area is we add both of those up. So 135, 216 gives us 351 square feet for that garden. Okay, so here's where it comes into play. Why does this matter? Alright, well, part B says that this lady wants to buy mulch for her garden. 1 bag of mulch covers 12 square feet. We just figured out how many total square feet she has. Now we need to cover with bags of mulch. So with it, every bag is 12 square feet, and we want to find how many bags she'll need to cover all of it. Okay, well, when you do that, all we're doing is we're dividing that total 351 square feet by a bag of mulch, which is 12 square feet, and it gives us 29 1/4, or 29.25 bags of mulch. But the thing is, if you're buying mulch at a store, you cannot go in and say, I want 1/4 of a bag of mulch. So you have to buy an extra bag to complete that for that 1/4 bag of mulch. And that's why, instead of having the answer be 29.5, in real world situation, we got to buy 30 bags, or we're going to be short. So that is how many bags of mulch it would take to mulch that entire rose garden. Alright, so let's continue on. Alright, well here we've got another example. It says the diagram shows the floor plan of a hotel lobby carpet. Costs $3 per square foot. How much will it cost to carpet the lobby? Well, we got this nice little lobby right here. It's got two trapezoids, so we can do. Do we remember the trapezoid equation? Let's say we don't for this one, okay? So, alright, well, if I don't remember the trapezoid equation, what else could I break this into? Well, it looks like I can still do pretty much two steps if I understand that if I break this into a rectangle in the center and two triangles on the outside, I can know that these two triangles are going to be symmetric, so they're the same, but they're just flipped. So with that, they're going to have the same area value. So we'll just double whatever we find for one triangle, and then we'll add it to the center rectangle that we're going to solve for. Okay, so that's how I'm going to work through this equation. Okay, so this is number 5. Let me fold up my paper so that I can not be showing everything else that I was working on. Alright, so number 5, boom, we have, I want to find, let's label what I'm doing. This is going to be, I don't know if this is a square or not, so I'm going to do AR for rectangle in the center. AT1, AT2. Okay, so, or they aren't A's yet. This is just labeling. This is T1, T2, and R. Okay, so T1, R, T2. So now I want to find, let's say, area of T1. Okay, so I am finding area of T1. How do I do that? Well, area of this triangle, it's going to be this whole part right here. I need to find a base, which is going to be this right here is my base. And my height is this little part right here. So that's my height. So with that, my base times my height, let's see, what would my base be? If I look over here, I've got that it's 15.5 from this dotted line up and 15.5 feet down. So if I add those two together, I've got my total base for my triangle. So 15.5 plus 15.5. Let me show that. So let's do, I'm finding the base is 15.5 feet plus 15.5 feet. And that gives me 31 feet. Okay? How about my height? Well, I know that from this point to this point is 42 feet. And that the triangle starts after 30 feet of it. There's going to be the two triangles. Okay? So 42, let's see, height. I have 42 feet that I have total that I was shown. I want to subtract 30 feet from it to see what those triangles are going to take up from it. So I'm going to have a total of 12 feet for both triangles. And to figure out, this is for both triangles. And for one triangle, it's going to be 12 divided by 2. Let me not skip on this. So one triangle, 12 divided by 2 is 6. feet for one triangle. Alright, so now we know that our height is 6 feet, our base is 31 feet, and we're trying to find the area of the triangle. So if we go back up to area of a triangle, let's bring that down just so I'm working in the right spot for it, since we found all our stuff that we need. Area of a triangle 1 is going to be 1/2 of our base times our height. 1/2 times my base of 31 feet times our height of 6 feet. Okay. So, one thing that I like to do, since I don't want to have and work with a 15.5, I want to flip these. Based on the commutative property of multiplication, it says that you can multiply any one of these in a certain specific order or different orders, and we'll still get the same value. So I'm going to actually flip it around so that I'm not working with 15.5, but I'm working with 3 instead. Because if I multiply 1/2 of 6 feet, I'm going to have 3. And you'll see why it's easier in a second here. So 6 feet times 31 feet is 3 feet times 31 feet. And 3 times 31, that is 93 feet. I didn't even have to try to figure out any decimal points, anything like that. I can easily just do it in my head. So that's why I wanted to switch it around. So I found that the area of one triangle, area of T1, is 93 feet. Okay? Well, guess what? Area of T2, 93 feet. Okay, now we need to find the area of the rectangle. Okay, so why I said area of T2 is 93 feet? Because this side and this side are mirror images of each other. They're the same area, they're just facing the other direction. Okay, so now I have, it looks like, a height of 31 and a base of 30. So, area of a rectangle is base times height, or we have 30 feet times 31 feet. Alright, so 30 times 30, that is 900. 30 times 1 is 30. So our total area is 930 square feet for the area of the rectangle. Okay, area total. Is going to be AT1 plus AT2 plus AR. So 93 feet, square feet. I didn't put squared. 93 square feet plus 93 square feet plus 930 square feet. Okay. And once again, I don't want to add it in my head. I don't want to mess it up. So 930 plus 93 plus 93 is 1,116 square feet. 1,116 square feet is my total area for this image right here. Okay? So that is the work for that, number 5. Alright. So then, we get into a couple other questions here. How about in this guided practice section? It says, in the diagram, the area of the large square is 1 square unit. So this entire area in here is 1 unit. Okay? The two diagonal segments divide the square into 4 equal-sized triangles. Alright, so this and this give us 4 equal-sized triangles. 2 are white, 2 are multicolored. Alright, 2 of these triangles are divided into smaller red and blue triangles that have the same height and base length. Okay, so we're evenly dividing right here for the red and blue. Alright, find the area of the red triangle. So we're looking for basically just that right there, just one red triangle. Now with this, we see that it's 1/4 of the square unit gives us just this part right here. If it's 1/4 of the square unit right now that is between red and blue, well, half of 1/4 is 1/8. So this square, or this red unit right here, or this red triangle, is 1/8 of a square unit. Okay, so that would be the area of that red triangle. One red triangle is 1/8 of a square unit. Okay, kind of tricky. There's not really a way to solve it out other than just understanding fractions of an image. Okay, so the next one we got number 2 here. We got this laying down L shape here. With that, I already solved this before, and I decided to break it into 2 different rectangles, and I called it R1 and R2 already. Okay, so this is number 2 here. I want to find the area of that polygon, so number 2. And I've broken it into R1, so AR1, what would that be? Well, it looks like it's going to be 10 feet for the height and 4 feet by the base. So we have base times height for my area, so we have 4 feet times 10 feet. And that one we should know immediately is 40 square feet because of our tens factors. And then rectangle 2. We have base times height again for our area of a rectangle. The reason why I keep writing it out, what the area is so it's cemented in my brain that I'm not going to forget what the area of a rectangle is. So if you get stuck with like trapezoids and things like that, make sure that you write out what the area equation is every single time so that you remember how to do it. Okay, so my second rectangle, what do we have? Well, if we notice that we have a height of 10 here for that first rectangle, but it continues on to give me a height of 14, that means that 14 minus 10, this height is 4 feet. Okay, so now we have a base of 18 feet times 4 feet. So 18 times 2 is 36, times 4 is 72. So now we have 72 square feet. I want to find the total, so area total is going to be AR1 plus AR2, or 40 square feet plus 72 square feet. 40 and 72, that's 112 square feet for our total area of this L shape right here. Now number 3, this is one where we kind of follow that example where we complete a rectangle and then we find the missing part. So what I want to do is I want to find the area of this completed rectangle that I'm drawing out here. So a 20 by 10 rectangle. Let's make it so I'm only showing work for this one. Okay, so number 3, I'm finding the area, and I want to find a rectangle minus a triangle. Okay, so rectangle, area of the rectangle is going to be 20 times 10. So area is base times height equals 20 meters times 10 meters. And that will give us 200 square meters. my triangle, area of the triangle that I'm looking for. Well, I see that my height is 8 here, and it's 10 on the other side. So height is 10 minus 8, or 2 meters. And so we're going to put 2 meters here. And then my base is going to be 20 meters minus 16 meters, or 4 meters. Okay. My total area is 1/2 base times height for a triangle, which is 1/2 of 4 meters times 2 meters. And that's pretty much 2 times 2, or 4 meters squared. So I don't add these because I made up that triangle that's going to be in that right corner. That means that I need to now subtract it out of my total. So area total equals area of rectangle minus area of triangle. And that's going to be 200 meters squared minus 4 meters squared, or 196 square meters there. So that's what we're looking for when we're trying to find something like number 3, is we'll find that it's 196 square meters. Alright. And, let's see, I am going to work through number 4 here, and then we'll finish up with this video. So, number 4, it says, Jess is painting a giant arrow on a playground. Find the area of the giant arrow. If one can of paint covers 100 square feet, how many cans should Jess buy? Alright, so we want to find what is the area of this. Well, if we're looking, how can we break this apart? I easily see that we have a triangle and a rectangle. So I'm going to have this as R and this is T. Let's find our heights and bases for everything. I want to do the area of the rectangle is base times height. What's my base of that? It looks like it's 18 feet. How about its height? 10 feet. Shows it right here. So 18 times 10 gives us 180 square feet for our rectangle. How about area of the triangle? Well, now we see we have a, let's call this our, we're working on height here. So for height, we have a total of 24 feet minus 18 feet. We're going to have 6 feet. This part right here is going to be 6 feet. Because 6 plus 24, or 6 plus 18 gives me 24. And then my base. What is my base? It looks like we have a base of 10 feet plus 5 feet plus 5 feet. As it see, we have 5 feet sticking out on each side for this arrow. So my total base is going to be 20 feet. Area of a triangle, 1/2 of my base times my height. 1/2 of 20 feet times 6 feet. 1/2 of 20 is 10 feet times 6. 10 times 6 is 60 square feet. So now, what is my total area? Area total is AR plus AT, my triangle and my rectangle areas, of 180 square feet plus 60 square feet. That's going to give me 240 square feet. Okay, So that's our area. But what is the actual question? You always, if it's a word problem, make sure you're figuring out, are you answering the question? It says, if 1 can of paint covers 100 square feet, how many cans of paint should she buy? Is it looking for area? Absolutely not. We're looking for cans of paint. So, 100 square feet, 1 can. Can we buy whole cans? No, but let's see what we need. So we have 240 feet squared, and each can is 100 feet squared, so we're going to divide it out by that. When you divide feet squared over feet squared, we're just looking at a number, and it looks like 2.4 is how many cans we'll need. 2.4. Can we buy a 0.4 can of paint? No, we cannot. Therefore, it's approximately 3 cans of paint. Alright, so that is the final one for today. Thank you for watching, and have a great day.